Welcome back. This is Mrs. RRubright with Advanced Geometry. Today's lesson is 9-6, Identify Symmetry. How many lines of symmetry does the hexagon have? So what do you guys think on this first one? One, two, any more? Or it'll fold perfectly on top of itself? You think it's just two? Two lines of symmetry. How about the next one? One. Anything else? Two. What else? You think this will fold perfectly? 3, 4, 5, 6. Think I got all of them? 6 lines of symmetry. How about over here? How many lines do you guys think it is? Just one? Nope. If I fold the piece of paper exactly on the line, it'll be perfectly on top of each other on any line of symmetry. So over here, how many lines of symmetry? Let's get started. How about 1? What else? 2, 3, 4. Anything else? 5, 6, 7, 8. I'm pretty sure I had a couple of them connected. It was 8. How about on this next one? 1. Not connected. 2, 3, 4, 5. Anything else? What about with the ram?
1.
Just 1?
Yeah.
Perfect. Draw a hexagon with no lines of symmetry. 1, 2, 3, 4, 5. Maybe I should have went to like here or something. 6. Let's get my eraser. Something like that. Any 6-sided object that's just kind of free-form, doesn't have any lines of symmetry. They just did one that looks more normal, but just kind of lopsided, different sizes. It's not like, it's not regular. It's not all the same size and shape, and angles and sides are not all congruent. There's nowhere that we could like fold it in half and have it be perfectly on top of itself. Theirs was convex, mine was concave. I kind of tried to make mine look a little more crazy. Parallelogram. Does the figure have rotational symmetry? If so, describe any rotations that map the figure onto itself. Will this ever look like this? Any degree that I can rotate it where it looks exactly the same. It never looks the same until it goes all the way back to where it was. So no, it doesn't have any rotational symmetry, right? Because it only looks like that there. If I rotate it with the point being to the right, it doesn't ever go have the point all the way to the right unless I go all the way around to 360. Or do they have it at 180? Were you guys watching? At 180 it did. Look, at 180, we're going to go halfway. See it? Half of a circle. 180. Only 180. So at 180 and 360. So it only has rotational symmetry of 180, nothing else, right? It's the only time it looks exactly the same. How about a regular octagon? Gonna look the same a lot. This point right here, if you had this point there, 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 it would all look the same, right? So like, if I went like this. See how when I rotate it looks the same again? I rotate it again. Same. 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 So how many degrees? Every time I rotate it, how many degrees does it look the same? Well, this is 8 sides. I have 8 slices of pizza. 360 degrees is a circle. 360 divided by 8 is how many degrees? How many? You guys, 360 divided by 8. 145?
45.
Yeah, I knew it was not 145 because that made no sense. So every 45 degrees he's saying. So let's think about this. 45, 45, 45, 45, 45. Does this make sense? It does, because that would be 90 and 90, which is 180, right? All right, so every 45 degrees. So it has rotational symmetry at 45 degrees. 45 plus 45 is 90. 90 plus 45 is 135. 135 plus 45, 180. They only, in this textbook, want you to do rotational symmetry up to 180. So at 45 degrees, 90 degrees, 135 degrees, and 180 degrees, it looks the same. Trapezoid. Does a trapezoid have rotational symmetry? Will it ever look the same? Where's its lines of symmetry? 1. All right, so now let's take this. That's 180. It never looks the same until I get back to 360, so does it have rotational symmetry?
Yes.
No. It does not have rotational symmetry because no rotation of 180 degrees or less maps the trapezoid onto itself. Rhombus. What do you guys think? Yes? Well, how many degrees? So you think it's 180 degrees? Anyone else? Someone thinks it's 90 degrees? It is only 180. Think about it. It's just like before. Let me show you, just so you guys can see this. This is where they currently are. Watch. When will it ever look exactly the same? Okay, that's not really proving what I'm trying to prove. Okay, maybe it's, why is it attached to this part? Whatever. Yeah. Oh well. Okay, so at 180, you can kind of see if I flip this exactly upside down. If I put this, if I just shifted it, it would be the same. It's because it's attached to the words, that's why. So at 180, it's the same, and then it's never the same again until 360. So it has 180 degree rotational symmetry. How about this guy? This one's easier to see, right? What do you think? each of these points could be rotated to here and it would look exactly the same. Does that make sense? So if we split that up, it's every what? Every what? 90 degrees. So 90, 180, 270, 360. They only went up to 180, so 90 and 180. Right triangle. No? All right. Identify the lines of symmetry and rotational symmetry of the equilateral triangle at the right. All right, so how many lines of symmetry? You have 1, 2, 3. So we know that it is not C and it is not D. Rotational symmetry. When will it look the same? It'll look the same, this, and this. If this vertex is here, or if this vertex is here. So every how many degrees? If I'm splitting it into thirds, 360 divided by 3, 120. So at 120, 240, 360, it looks the same. So 120 degree rotational symmetry. B. Describe the lines of symmetry and rotational symmetry of a non-equilateral isosceles triangle. Non-equilateral isosceles triangle. These two angles are equal. These two sides are equal. Lines of symmetry. How many? Just one, right? How much rotational symmetry? Of a non-equilateral isosceles triangle, what's the rotational symmetry? None. Your altitude is your line of symmetry, your height, and has no rotational symmetry. That is everything on 9.6, Identifying Symmetry. I hope you enjoyed the lesson. Subscribe to our channel and like the video.